Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with your Unit 3 homework here. So, alright, number 23, this 1,800 kilogram car is moving at 12 meters per second. You notice it doesn't say anything about speeding up or slowing down, so we're going to presume that 12 meters per second is constant. So let's see, find the force between the road and the car at the two locations. So what you want to do is start with a free body diagram of the car. Well, I'll start with this location here. And one of the things that people tend to make mistakes of is basically adding extra forces. Remember that forces come in two types, field and contact. The only field force in this problem, or in any other typically first semester physics course, is the gravitational force. And then the rest of them are direct physical contact. So my clue to you is your free body should only have two forces in it. All right, then you have to recognize that there's an acceleration here, even if the 12 meters per second is constant, because the velocity of the car just before the picture is maybe something like this, and just after something like this, right? So if this is your v initial and this is your v final. And remember how these vectors work. Your v initial plus some sort of change in velocity equals your v final. Right? So the change in velocity is upward, right? So hopefully we recognize, okay, there's an acceleration there and what type it is. So once you draw your free body, then write a force equation, right? Sum of all forces equals ma. And remember my standard rule of thumb, identify the acceleration direction, call that positive. So this is a centripetal acceleration, so that should tell you the acceleration direction. All right, for the second location, it's virtually the same, right? The free body is going to be very, very, very similar, only two forces. But what is different is the acceleration direction. Look at the velocity of the car sometime just before. I'm going to call that a v initial. And sometime just after, there's a v final, right? And hopefully you can visualize from that which way that car is actually accelerating. When you write your force equation, my standard rule of thumb, remember Captain Rod's rules of thumb, I call them carrots, identify the acceleration direction, call that positive. When you look at this curvature here, the center of curvature is down here somewhere. Okay, the next thing here, find the force between the 70 kilogram driver, got to fix that, and the car at the location shown. So this is virtually the same. It's just your free body is going to be of the driver, not the car, but it'll be very, very, very similar. So that should get you through number 23. I hope that this helps. Have a great day.